our next participants in the competition. We have Amsel. Now, Amsel is based in Germany, and Amsel is actually an acronym for Advanced Materials and Surfaces for Environment and Life. So I invite Salman Syed onto the stage to give us some more background and information.
Just to start, well, it's a little less direct product for use at home, so that would be a little bit different. What we want to do is not to compromise the quality of products and of people's life, whereas improving the ecological effect of the processes and making the surface treatment and the material manufacturing as clean as possible. So, well, we all can imagine a world where electronic devices are really reliable and your car electronics doesn't break down randomly at any point, or where the cleaner process alternative is technically better and not that you still require plastic because it breaks, or where you can breathe freely and safely in a production line, and finally, with all this, you attain your climatic goals of CO2, zero CO2.
Yeah.
Well, it might look very big, but we started with the idea.
That's okay, yeah.
So
Thank you.
how to improve the electronics, and we really restart with the problems associated with electronic failure. Two of the main, well, the biggest electronic failure comes from the corrosion of the electronics in the long run, which is and that comes because of the improper housing. So you have got humidity diffusing in, you have got flux residues, or the porous coating that is present on its surface. On the other end, there could also be improper cooling, and you have the burning of components through improper interface or a solder that is not of the required quality. Imagine that there would be something, let's say a flame, or something that could treat and modify the surface in such a way that you can produce the interface you want, and you can get rid of a lot of chemicals that you use to make the process, and you can make the process really clean. Well, so just to start with the housing process, I started saying, yeah, if we could have a great housing and we could have a sealed, components are well sealed, then you do not have the corrosive elements coming from the environment. So today in automotive industry, they are putting in the electronic components in housings, which are to be bonded, and that bond line has to be prepared with alcohol, and then it has to be treated with either application of primer or a plasma. Then it requires an oven so that it becomes ready to use. Now, what we tried to do, let's say that imaginary flame treats the surface and all the dirty organic elements just fly away, and at the same time the surface becomes bondable. Well, that could be tomorrow's alternative. And with the same idea of changing the surface in such a way, we could also create the surface of electronic PCB boards such that you have got the surfaces with surface energy that would allow the conformal coating to bond to it and cover it much better. That means you would require a thinner amount, a lesser thick coating, and a coating that covers it completely, thus allowing it to be completely safe and without bubbles, thus providing a better thermal transfer and a better insulation at a lower thickness. Well, and it could also be that imaginary flame could then replace the fluxing process, and the flux is one of the main reasons of the corrosion and the failure of electronic devices, where you need to apply the flux, then you have to heat it, then you solder it, and then you have to make sure that you get rid of the flux by washing it. And most of the time, it is not gone, so it's still there. Well, let's, for one moment, imagine we could create something, the same flame, imaginary flame, can treat that surface and then make it solderable in at least as good as what flux does. Well, so maybe it is not as imaginary as we think. Maybe this is just a simple flame that goes on top of a copper surface, and then it modifies a copper surface that never solders to something that solders perfectly. And if you compare it with the classical flux-based process, you can see the flux residues here where there are none here. It could also be used for any typical surface which is very oxidized. Well, the problem is not solved. We can also find out by using this, we can reduce the time to solder, which something came to mind which I didn't have in mind till the time I met someone here. He said, oh, there is something you are not talking about at all. The thermal energy that's now required to solder is reduced. Thus your high power elements do not see a lot of heat before they go into the production, thus prolonging their lives. So far, so good, but could it be that the alternative process be better also in the quality of the solder that is achieved? Apparently, when you have a flux, the flux evaporates, it creates holes and bubbles and voids that are observed into the interface of the solder with your PCB board or with any surface. Well, if you can create a fluxing which has no residue that is staying over there, then you can literally be able to produce this no void surface. Could you please then handle them? And you have some samples here to see that it is really not an imaginary flame anymore, or it's not an imaginary process anymore. So what is the magic behind it, and why are we so confident that it is something that could really change the future? Why? We only use, and the first step, electricity, water, and air combination. By playing around on the hydrodynamics, on electrodynamics, we are able to create a flame that has it does not contain any carbon, so there is no CO2 emission, and we contain no VOCs, and what we have optimized as well, that there are no NOx that are being emitted. Only the resultant product or byproduct is water vapor. So if you look at the simple process, we have electricity, we combine it with water and air, we apply an electric field, we create this particular type of flame, which then does treat the surfaces. We modify them from hydrophobic to hydrophilic. We can modify or oxidize or reduce the surfaces. Well, the advantage is also that it's very safe. It could be used for any application of surface treatment where you can bond and you are able then to solder, or you can create a perfect bond, which is valid for most of the surfaces and any bonding that is happening all across the industry. On top of that, if you think of it by changing the material properties, we can also improve a lot of materials around us. So to the safety, in terms of safety, we can achieve it in open air without any danger of having any toxic emission. You do not require any cylinders, you do not require any gas components. You just have a very long life components and a very reliable system that runs for at least 20,000 hours. We have already tested it to 3,500, but still we know with the accelerated test that it would stand that. What is the alternative today? The dirty chemistry, or those who claim otherwise the flame, well, it's not very visible, that emits CO2, or the classical plasma that create NOx. So just to finish it off, we don't need to, that's our team of 2 people for the moment, but we will be able to soon make it larger in the coming months. We are expected to be on the market in Q2 2023, and I'm thankful for your attention, and if you have a question, please ask. Thank you.
Round of applause there for Salman. Round of applause for Salman from Amsel. It's a very interesting technology. It's something that I first had to deal with. I was working with a colleague, and he brought in some electronics from his car from home that stopped working, and fully corroded inside, having sort of been in the trunk of the vehicle. So let's give our audience an opportunity to ask questions. I'm just going to have a look around. Justin here is going to take the microphone for us to CJ.
Hello. The size of the unit, the form factor?
So at the moment, that's very big. So for my liking. So it depends on the power that you require. Typically, we are going to house it in a PCU, a typical unit of a PC, basically. That's what we are aiming for. Right now, it is 60 centimeters by 60 centimeters by 80, but we are going to reduce it to a PC unit. And the power range that we can achieve is between. There is no lower limit, but we don't want a very low limit anyway. So from 1 kilowatt, and the use could be from 30 watts, the flame could be generated from 30 watts up to, we can go up to 100 kilowatt, but I would not try that at the moment. But technically it is possible, we know it is possible.
I think we have another question from the front here, from Eric.
Yes, congrats on your invention. I was wondering, since it seems to have a bit of an urgency, right? The planet kind of needs this type of inventions. How do you choose your distribution model? Is this licensing? Is this something that you are going to do yourselves? It's not a big team, so how are you looking to move forward?
Because we are going to expand our team a little bit, so our idea is to have a centralized knowledge and treatment center, and for distribution. At the beginning, certainly we will find partners in different areas, because if you look at it worldwide, we've got 3 to 4 big hubs, which is, one of it is certainly Asia and Southeast Asia. On the other hand, you have got US and Canada, and third is normally Europe. However, if you look at it, at the beginning we would require distribution possibilities. At the moment we are really directly dealing with the potential clients. We're very small, as you know, but in the coming months we will be finding out partners in different areas of the world. And for Europe, at the moment we will try to distribute it ourselves as much as possible, and from there on we will start to create our own centers in different parts of the world.
Super. Well, thank you very much for that opportunity to pitch your solution. Amsel, Salman here from Amsel. Thank you very much. Super.